Hello and welcome back to Calculus 1 Exam 1 review, right? You chose to have this exam next class, so let's take a look at the details of the exam. Don't forget about the office hours, the SI session, the tutoring center, which is open 12 hours a day, and all other bells and whistles that you have online. Before I write anything down, I will mention one more time whether you have it or not have the online account. You should make a temporary account today because the quizzes will start tomorrow. And take the Chapter 2 post-test, which is a sample exam provided by the software. If you do that today or latest tomorrow, you will have your preliminary test grade. So when you do the entire test, the software will grade it back just like it's grading your homework. And clearly, if your grade is 38, there is some work to be done. If the grade is 73, there is less work to be done. And if the grade is 93, there is still work to be done, but not that much.
So just do the post-test?
It's the post-test, and I will log on and I will show you the post-test. There is a pre-test, which is the stuff you need before you go to Chapter 2, and then there is a post-test, which is after you complete Chapter 2. Those are the same exercises that you see, the homework and the quizzes, so there are no curveballs there. But again, if you take that, you know, in a controlled environment, which means no notes, no graphing calculator, no music, no videos, or anything like that, you will actually have the real metric on how well you're doing in class at the point, so today or tomorrow. And then you have a week to fix it if there are issues. If you do this test, you know, next Friday is completely useless because you're figuring out that your knowledge base is like 45% and the test is the next day. You might as well just sleep through. Quizzes will open every day at 6 a.m. and close the same day at minute to midnight. And they will start tomorrow at 6 a.m. So if you do not have the account, make the temporary account, try those quizzes. You need to pass a quiz with 70 or more so it counts towards your grade on the test. Anything that is less than 70, all I get on the other end is binary result. It's 0 if it's 0 through 69, and it's 1 if it's 70 through 100. It used to be 80, which was better, obviously. But now it's 70, and clearly 100 will always be better than 70, so, but on my end I see 1. So it's okay to keep retaking these quizzes over and over and over again within the 18-hour period. So they open at 6 a.m., and you can take the quiz 15 times if you want to. The waste of a quiz and time is if you open the quiz and then you are matching the problems to the notes and then you are spending 3.5 hours on a quiz. You are supposed to test your knowledge with a quiz, so just take it and, you know, without anything, and then the next time you take the quiz, the same problems with different numbers. So the idea is to see what you don't know and learn that thing per given day. Which is the reason why the students who do these quizzes do, you know, 20 to 25 points better than those who don't, because on a daily basis you're learning new things and you're polishing your skills. So you must be superior to those who actually don't have that type of a practice. Plus, obviously, the points that you get that are for successfully completing those quizzes. So you should take the post-test today to identify the weaknesses, and you should start with the quizzes tomorrow morning at 6 a.m. The quiz is open all day, and it's one quiz per day. They open in the morning and they close, and there is no reopening if you miss, because this is not mandatory work. Well, even if it's mandatory, you still missed it, so that's it. So quiz 1 tomorrow, quiz 2 on Monday, quiz 3 on Tuesday, and so on. The last quiz is on the day of the test. And generally, since your class is so early in the morning, I open the 7th quiz the day before, but it's still due on the Saturday by midnight. So you may opt to do that quiz after you take the test, which is pointless. But you know, you'll have 2 quizzes technically on Friday in that case. It's just the curse of 8 a.m. class, right? Or you might get up at 6 and do the quiz before you come here. You all heard that Ali unfortunately cannot be here on at 7:30, and I will try to get another SI who's currently working on differential equations. And if he can't be here, then I can be here. I mean, I can be here anyway, but it's better if you have a student perspective to answer questions. Yeah, that's 7:30 to 8:30 for additional questions, and then 8:35-ish, 8:40-ish is the exam, and that's that. If for whatever reason you think that your car is coughing right now and might not make it, that's when it's time for you to start calling people and having this, right? I'm gonna Uber here or teleport if you figured out how. There are many options that you guys can exercise to make sure that you are here no matter what. If you break your arm, you have the other one. You have to learn to write the other arm. It's fine. Technically that's it. No graphing calculators. That's another one that it's the rule of RVCC. No graphing calculators on the exam. And yeah, so I'll ask you for the questions, but let's first take a look at the list of topics and things. So it's chapters 1 plus 2, but chapter 1 is the Precalculus review, which was our first day. And from chapter 1, we are focusing on graphing functions. Oh, sorry. First, definition of a function. I told you that's definitely there for 4 points. So you either learn what I wrote on the first day. Function is a rule which assigns, no, right? So definition of a function, and that's the question on the test for 4 points. Then the next one we have graphing. So in the Precalculus book, that's 1.6. I'll just put in Precalc. You guys have the access for free to the textbook that we use for Precalculus. Doesn't matter which edition, 3, 4, 5. They're all downstairs in the tutoring and in the library. So these 3 sections, function composition, so f of x composition, so you are able to create the difference quotient and so on. That's 1.7 Precalc. And inverse, 1.8 Precalc. I am giving you the sections in the Precalculus textbook. So these are all Precalculus textbook sections, which we at RVCC teach in Precalculus1 course. And these sections apply to all functions, even the ones that you will learn in Calc 2. Calc 2, you're learning hyperbolic functions. All of these things apply to those functions as well. So that's the general function knowledge. Graphing contains shift, left, right, up, down, reflect, all of that good stuff. Function composition is asking you to compose or decompose functions, maybe look at their domain. And then finally inverse, to test if the function has an inverse, and then how to find the inverse as well by swapping x and y and shoveling through the algebra. So that's that Precalculus part, which is actually all in chapter 1 of our Calc textbook. And then we are moving to chapter 2, which is limits. And here we are going to have calculating or solving limits by, and now I have graph plus chart. That's your 2.2. I guess put little pluses over here. Algebra 2.3. This includes what we did today, earlier. And then we have infinite limits. Plus vertical asymptote, which is 2.4. Limits at infinity. Plus plus what's EB? And behavior, thank you. So all of the concepts that are in 2.5. We have 2.6 continuity. Which is 2.6. And then limit definition. So 2.7, but it's only the definition. So for every epsilon larger than 0, there exists delta larger than 0 such that formula, and you're done, right? So that's that definition. I had that in class notes. So I have to upload that before we leave today. So this is it. This is the list for things. So now, anything that is state the formula or state the theorem or definition, those are the freebie questions. So I already said definition of a function, but then you have the important theorem that says that the overall limit exists when the left and right limits are the same. That's an insanely important definition. The three rules for continuity, right? F of A exists. Limit of f of x exists, limit of f of x equals f of a. Those three rules, continuity at the point. The next one is function is globally continuous if it's continuous at every point. So those important things, those are all freebie questions because clearly you can't do any problems if you don't know those questions. Formula for difference quotient, formula for, you know, all different things that we did. So those are freebie questions, and then you have the questions with limits where you compute and you get the value, I don't know, 7 as the answer or something, and then infinite limits. Now, when we talk about asymptotes in calculus, we always take limits. So if you see the word asymptote in the statement of the problem, and you don't have limits in your answer, you are doing the question wrong, clearly, right? So the question can state, what is our, whatever, the asymptotes for, and then you have, let's say, f of x equals to x minus 3 over x squared minus 4. So what you have to do is go, okay, x squared minus 4 equals to 0, x squared equals to 4, x equals plus minus 2. Now generally this is where you would stop. In your pre-calc, circle this and you move along. But now you know you can't. Because we had those issues where one of these, right, because now we look at all of the problems that exist in a galaxy. And you know that sometimes the numbers that you get here are vertical asymptotes and sometimes are circles, not asymptotes, right, open circle. So you actually have to do the limit every time. Now in this case, you would have to say, okay, limit x approaches 2 from the, let's say, right of x minus 3 over x squared minus 4. You can't plug in the value, so the next natural thing to try is to factor and see if anything cancels. Now that is also not happening in this problem because it's really evil. So you can't plug in, which is the method number 1. You can't cancel or rationalize or something like factor. So that's method number 2. The only thing that you have left now to do is the chart of values, because you exhausted all other methods. You can solve every problem with the chart of values, but that's the really annoying way to do things, right? Because you have to compute all of those numbers in your calculator. So since you can, so here I'll write it since it's review. So can't plug in, 0 in denominator. I'll just put can't do algebra. I mean, I can, but doesn't help us. Can't do algebra. Nothing cancels. So what's left? So sad face. Have to do chart. So now what do I have to do? I'm approaching 2 from the right, so 2 should be on the left. Common sense, right? So put 2 over here, and then say $2.10, $2.01, $2.01 of the cent. So this is me approaching 2 from the right, being 10 cents away, being 1 cent away, being 1/10 of 1 cent away. So closer and closer and closer and closer. Then you take your non-graphing abacus and you go 2.1, oh actually parentheses, open parenthesis, 2.1 minus 3, close parenthesis, open parenthesis, and then we have 2.1 squared minus 4, and we have negative 2.195. Perfect. Then we go and we have open parenthesis 2.01 minus 3 close parenthesis divided by open parenthesis 2.01 squared minus 4 close parenthesis to get negative 24.688. And finally, if you know how to use vars, you can do this much faster, but then that will require you YouTube and learn something new. And some people are allergic to it. So, I don't know. Negative 249.688. As I look at the trend, as I am getting closer, I see that my numbers for y values are growing by a factor of 10 as I go, right? 2 times 10 is 20, 20 times 10 is 200, and so on. So this is growing by a factor of 10 about, right? So this is definitely going to negative infinity. So now, I'll put this in parentheses. We know that definition for VA is limit f of x as x goes to a plus equals plus minus infinity, right? So if the answer goes to infinity, then it is vertical asymptote. So now I can claim there is vertical asymptote at x equals 2, because we approached 2 from the right and we got negative infinity as the answer. And the definition for vertical asymptote states that if you get either positive or negative infinity, you have a vertical asymptote at that point. And now you have to redo the whole thing for -2. So redo all of this, because we just checked +2. -2 could also be open circle or asymptote, right? So you have to repeat the whole series. So repeat all of this for limit x goes to -2 plus or minus whatever of our function x minus 3 over x squared minus 4. Now you know immediately to go to the chart, because again canceling doesn't work and you went through all the hoops. So now you are approaching -2 from the right. And that's going to have -1.9, -1.99, and -1.999. So these are the values. Yeah, you take your calculator and then you get this stuff. You will still get another infinity. So the other one will work out as well to be VA. So I'm just going to put over here. There we go. Just do it. And then you will actually get another VA at x equals -2. So you are going to get that, but so you fill in the blanks when you practice. Horizontal asymptote, the same thing. You have to crank the limit, right? So same question, any horizontal asymptotes. In this particular question, you go limit x goes to infinity, x minus 3 over x squared minus 4. And then you know that you are supposed to divide each one by the highest exponent, because you learned, right? So divide x squared, divide x squared, divide x squared, divide x squared everywhere to get your next line to be 1 over x minus 3 over x squared divided by 1 minus 4 over x. And by that formula, which I wrote that the limit of 1 over x to the n is 0 as x goes to infinity, positive or negative. So x goes to plus minus infinity, whatever. So this was the formula. By this formula, all of these guys go to 0, and you end up with 0 over 1, which is 0. So horizontal asymptote at y equals 0. This is a lot of information for chapter 4. These will be, you know, what you see here is about a quarter of a 4.3 problem, right? You have to graph a function by hand. So what you did so far for that particular problem in chapter 4, you know that there is a horizontal asymptote and that there are 2 vertical asymptotes here. And now you have to compute x-intercepts, y-intercepts, domain. You have to compute first, second derivative tests and things like that. And you will be able to draw any function. I'm talking about sine of ln x squared, right? You're able to do that by hand in chapter 4 without graphing calculator, because you will know the entire list of things, shopping list of things that you have to do to pull that off by hand, where asymptotes are the part of that list. So in calculus, the way to find asymptotes, horizontal or vertical, are going to be those definitions that we learned in 2.4 and 2.5. So make sure that if the problem says, right, asymptotes, you actually have the definitions with limits, which is the way we do the problems. Not just, you know, guess. If you go back to lectures we had, you will see the reasons, right, about me talking about open circle and so on. Yeah. When I look for vertical asymptotes, what numbers did I pick? Well, there are two things that we have to worry about. The first thing is the candidates for vertical asymptotes. In Precalculus 1, you learned that vertical asymptotes occur when your denominator is equal to 0. So this calculation here is where I set the denominator equal to 0 to find positive and negative 2, which are the candidates. Now, those numbers, positive 2 and negative 2, could be either a vertical asymptote or just an open circle, which is the reason why I have limits. The limits are going to differentiate between the two cases, which one I have. So now I am testing. You can put in positive 2 and then say approach from the right, which is 2 plus, or approach from the left, which would be 2 minus. Pick whatever, it doesn't matter. It matters in the problems like ln of x. If you are approaching 0, well, you can't approach from the left because there's nothing to the left, right? That makes sense when you draw the ln graph? But for these type of polynomial rational functions, you have functions from both sides, so it doesn't matter which one you pick. So I picked from the right. I don't know why, because I'm right-handed. There we go. That's why. Whatever. So you pick from the right, and then you just pick numbers that are larger than 2, but they need to be getting closer to 2 as you move along. So I said, you know, if you think about money, it turns out to work the best. So your goal is to get to $2. So you start with $2.10 all the way to the right, $2.10, then $2.01, and then a 1/10 of a cent. You can keep going, adding zeros. You can have 15 numbers if you want to. Now that's new, this thing popping up for no reason. But at least nothing is disappearing. So guys, this is your exam. And it's really interesting to see the way, you know, first calculus exam is always, you know, probably a really scary situation for you, but it's interesting to see how different it's going to be than anything that you did so far, because it's not just calculate, where the calculator is this main thing that you know, want to think about if you can divide numbers or whatever. There are also concepts here, understanding that without knowing the definitions and theorems, you are pretty much dead in the water for most of the problems. Some problems you are going to quickly identify and solve, and others you'll have to think a little bit about it. But it's the same procedure as the homework. So there, you know, it's not a curveball of any of these problems. It's just having a clear concept of what you want to do. And also, don't kid yourself to try to remember every single variation of a problem, because you can't. Remember that this problem, which I did with the rational function there, exists when you put in trig, when you put in e to the x, when you put in ln x, right? And then when you put the function combinations of those. So it's not just learning this one isolated case where you say, yep, I know it, and move along. You can make your own problem. What if I have, you know, e to the negative x divided by x plus 3? Does that change the situation? Then you try it and you see that it actually doesn't. So you know, until you try these things, you really don't know what to expect. So, and that's also one of the reasons why the first exam counts the least. It wouldn't be fair because, you know, you all should be blindsided, you know, coming into the test in terms of, you know, what the test looks like, because you haven't had the test in Calc 1 before. And it would be bad if the first exam, you know, you ever see in a course is 50% of your grade. So 10% on the first exam, and technically if you mess it up badly, and I'm saying like 38, then you still have chance at A, right? Because 38 is almost 40, and that's 4 out of 10 points. So you still have 90 after that. So you can, if you score 100 on everything else, you have 94 in your class with 38 on the first test. So, but don't take that as, oh yeah, I don't have to worry about the first exam because it doesn't count pretty, you know, that much. Because I just showed you that the vertical asymptotes are the part of the next section. We've seen in the lecture this morning that the limits are defining derivatives, which is next 2 chapters. You cannot skip a concept. There is no, as soon as you start treating any of the math courses as, I don't really get this one, but, 2 problems on a test, not a big deal. I'll fix it on that. No. That actually knocks out the entire chapters of stuff coming up down the line. Every concept you skip in calculus will come back to haunt you really bad. And Calc 2 is coming for some of you. So study each concept in depth. Utilize all of the resources that the school is offering for free. Office hours, SI, tutoring, all of the web content. It doesn't have to be mine. It doesn't have to be even English. Just, I'm serious. You type in limits in Google, YouTube, hundreds of thousands of videos. The lifetime of you just watching limits, that it will not end. It will not end.
So that question was vertical asymptotes. There's variations of finding the vertical. Like there's sometimes finding the vertical asymptote, you don't have to do
the chart,
right? Like if things cancel and
well, in that case, if the things cancel, you don't get the vertical asymptote. All right? You get an open circle if you have. So we had the examples. It's not in. I have to boot the other software. Hopefully, it doesn't crash.
Stuff in the homework where I would find the vertical asymptote, and I wouldn't.
Yeah.
Do the chart.
Infinite limits. Boom. So for the vertical asymptotes here, right? Oh, this is when I was still using the full software, so it's erasing stuff. But in this case, right, we looked at the graph and we decided that it's negative infinity. So yeah, it is vertical asymptote, and you can see it on the graph. But then, next example, it was no vertical asymptote. We didn't use the chart or the graph because when they canceled, you got 5 plus 5 is 10, and you're not getting an infinity. And the vertical asymptote definition is requiring you to get infinity, but you're getting 10. So it violates the definition. So if you get infinity, it's vertical asymptote. If you don't get infinity, common sense, it's not vertical asymptote, right? So in certain cases, when they cancel, you might not have a vertical asymptote, right? So these are the things that you have to be a little bit careful. Now here is the other, this is the evil problem, because now the cancellation happens, and for number 5, you don't have a vertical asymptote, but for negative 5, you do have a vertical asymptote. So when it cancels, the term which produces asymptote remains in denominator, right, or it's a numerator. So there are things to consider, a lot of things to consider in these cases. Again, this is the old app, so there's this part missing over here on the graph and so on. So these are the cases that you have. Also, what I've seen as one of the good techniques that students would do, take the piece of paper and just categorize, like make a map of chapter 2. And the map of chapter 2 is you put the limit on top, you branch off the 3 different ways of solving the limits, plug in graph and chart and algebra, right? And then examples for each, and then the infinite limits and infinity, they branch off as well. You can do that and make a map for you to see the entire chapter 2 structure. So there will be no questions to solve in terms of calculations and things from 2.1 and 2.7. But 2.7 has a definition that might be on the test for points, which is the definition of the limit, the epsilon delta definition of the limit, which we covered last Saturday. So that part has to be there. I mean, could be there. Definition of the function, I told you 100% it's going to be there. And clearly you're going to have a whole bunch of limits, right, to compute, and then connect them to vertical asymptote and so on. So a problem on inverse, a problem on function composition, a problem on graphing the function by hand, by shifting and flipping and all of that kind of stuff. 4 points, function definition. Let's all click out one. Yes.
The transformations, how like.
So whatever we did on the first day, where I give you a function and then you evolve it in time. So let's say you have f of x is equal to e to the x minus 3. This is really cheap, but let's do this one first. So you're looking at this function, you say this is exponential function. The default state of exponential function is this one going through 1. So this is just e to the x. And now minus 3, which is modification on x, is shifting the function 3 units to the right. So you will draw the next, I provide boxes usually, 3 units to the right. So this is your number 1, where the function used to go through. And now you move that 3 units to the right. And you just draw the same shape, and you label this as 3, 1. And you're done. So that is an example. Or, here's another example. Graph f of x equals to negative square root of x plus 1. Right? You're looking at this function, and what is the main function here? Square root of x. So you will draw the default state of a square root of x, which goes this way, goes from 0, right? And this is just root x. Depending on how much attention you how much you pay attention, when I talked about this, you have two different transformations here. There is a reflection and shift to the left. Good. So shift to the left, 1 unit. Now, I told you that when you have reflections, you do those first. So, reflection is done first, and this is a reflection on x or y? On x. Good. So, the next step in evolution of our problem is to flip the function down. And this will be negative root x. That's all it is. And once you have negative root x, now you will shift everything 1 unit to the left. So the origin, 0, 0, which is where the function used to begin, is moving 1 unit to the left, and you just go now, and you're done. I hope this makes sense, right? Good. Rest my palm. There we go. So this is the full function answer. So progression in time. Bueno?
How many questions total?
10, 12. If you yeah. Why, you want 300? You no, exactly.
Maybe like 30 though.
An exam is 5 hours, right? With 30 questions. I mean, the limit of stuff takes time. All right, try. So get all asymptotes. Y equals x minus 3. No, yeah. x squared minus 9. I'll be right back.
Yeah. And then you have to go from the left to the right because you need a chart for like negative 2.9, negative 2.99.
Well, I'm just trying to focus. I don't know that much. I'm not
Horizontal would be 0. Horizontal would have to go to 0.
Horizontal asymptote, yes or no?
Yes. Yeah.
Where? Very good. Do we have any vertical asymptotes?
Yeah.
How many? 1. Good. Where?
1.
At negative 3. Very good. Now, when you are
You still need, I mean, that's the thing, like, for the chart, I still made a chart
yeah.
for, as x approaches to the left and the right.
Well, you just need one. You don't need both.
So you want us to make charts?
When you have to.
So if you don't have to, you don't have to.
You don't have to, yeah.
Okay, cool.
So horizontal asymptote, we have the limit x goes to infinity of x minus 3 over x squared minus 9, but x squared minus 9 factors into x minus 3, x plus 3. And then these guys cancel. So you see that you are getting limit x goes to infinity of 1 over x. Yeah, x plus 3, but who cares? When you plug in infinity there, infinity plus 3 is still infinity. So that goes to 0, which means horizontal asymptote at y equals 0. For vertical asymptotes, you know that the candidates are x squared minus 9 equals 0, so plus minus 3, right? And when you do your limit, x goes to 3, let's say plus, you have x minus 3 over x minus 3, x plus 3. These guys cancel, and you're getting 1 over 6. Here I'll write in blood, not infinity. So, no va at x equals 3. No vertical asymptote there because we got 1 over 6. This is open circle. So 3, 1 over 6 is the open circle. The other one is limit x goes to negative 3. You can do right or left, whatever. And you still have x over 1 plus x plus 3 because the other one cancels. And now you get 0 in denominator when you plug in. So you can't use plug-in method. There's nothing to factor, nothing to cancel, nothing to rationalize. So the entire plug-in / algebra method fails. The entire 2.3 fails, which means you have to revert back to 2.2, which is graphs and charts. You either know the graph of this, and in this case it's easy, so you should, where you have the original function that looks like this, shifted to the left 3 units. So it will look like this. Right? And you see that it goes to, from the right, it goes to positive infinity. So VA at x equals negative 3. Or, if you don't like the graphs, you should like the graphs because you're in calculus, you will have the chart of values, 3, 3.01, 3.001, and you calculate the values, and you will see that the trend is to go to positive infinity. So whatever way method you pick, you choose, you have to get infinity, so you are going to have the vertical asymptote there. So for this problem, you had horizontal at 0 because the limit said so. You did not have asymptote at 3 because the limit said so. And you do have asymptote at -3, again, because the limit said so. Good? Yeah, I'm just going to stare until I ask you to ask a question. If you have no question, we can just leave.
So, if there's an intermediate value problem, how many decimal places do you want us to go to?
It's on the lab. End of the story.
How many decimal places do you want us to go to the lab?
Let me make it up now. 3.
Okay.
Is that just because your shirt said so? 3. You don't even know who picked your clothes in the morning.
I just forgot what it was.
Yes. Oh yes. The table is wrong. You are supposed to approach -3 from the right, in which case it's 2.9 and stuff like that. So -2.9, -2.99, and -2.999. Very good. Good catch. So the chart was wrong. Any other questions? Just questions about the concerns. Yes?
Would you be able to review the squeeze theorem?
Yeah, sure. Why not? Do you have a question?
I mean, just like seeing numbers that.
Yeah.
Yeah.
Ah. Okay, it's all about your questions and my answers.
I still don't understand the chart why, if you're looking at, I understand that since it's -3 is going down, but I don't understand why it has to be like -2.
These are x values. It's not going down. We are approaching x from the right. So if you have on a graph positive infinity, negative infinity, and you have your -3 over here, and the -2 over here, and -4 over here, right?
Right.
You have -1 and then 0 and so on. So if you are approaching 3 from the right, that's you walking on this line this way. That means that you are approaching 3, and if you take a look, right, it's going to be, you step at 2.9 first, and then 299, and then, right, at negative. So you can use this graphic, guys, visually to make sure that you are picking the right numbers. Approaching from the right means on the picture the same thing as what the words say. Approach from the right. Yes?
Can you also put a negative 1, 0?
No, they're too far. You want to be approaching. It's in the neighborhood of the, right? So you go, as you can see, I am 10. If this is $3, then 290 is 10 cents away. So that's what I say, 10 cents, 1 cent, 1/10 of a cent. I'm always closer, right? Closer, closer, closer. The day, the club you left right before something very interesting and not funny happened with the, come closer, I'll tell you later. All right, anything else? Oh, the squeeze.
So, 1 minus x over 2.
1 minus x.
1 minus x squared over 6.
1 minus x over 2.
X squared over 6.
like this.
Yeah. Yeah. Is less than or equal to sine x over x. Is less than or equal to 1. X will be x.
Okay. So, in this particular problem in a textbook, you were already given the two functions which are squeezing the evil function inside. If you are supposed to find the limit of sine x over x as x goes to 0, when you plug it in, you see that it doesn't work, because sine of 0 is 0, and you plug in 0 in denominator, it's 0. You have 0 over 0, and that tells you nothing. You can't divide by 0, so, right, you're stuck. Can't factor, can't rationalize, can't do anything. Now, no graphing calculator, so good luck graphing this, right? So you have a lot of issues looking at this problem. So instead, what they did is they gave you the functions which bound your problem. So the function on the left is below sine x over x, and the function on the right, which is 1, is above. So now, instead of solving the problem for this mean and evil function, you solve two associated problems independently, and if they produce the same limits, then the one that is squeezed in between has to have the same limit because it's squeezed in between. So now when you plug in 0 in the first one, this thing goes to 0 because, right, x goes to 0, and the answer for the whole thing is 1. On the other side, you don't even have to plug 0 because there's nowhere to plug it in. The answer is just 1. So you see that the left limit gives you 1, the right limit gives you 1, and by the squeeze theorem, the limit of sine x over x is 1. So that's what the squeeze theorem provides, right? Once you have an evil problem, hopefully you can find two functions that will bound your bad function, and then solve the easier problems to give the answer for the evil one. Bueno? Good. Yes?
Question. Regarding the lab, we have a similar problem there. Do you want us to do all work or just have a final answer?
Well, the final answer is just placed on the line. The work is done around the problem in the little space.
You want us to have a work?
Yes, because it's if the problem is wrong, that's the partial credit. If there is nothing there, you want us to do. You know, no, because less grading for me is better. So if you don't hand in the lab, for instance, right, I have nothing to do in that case. So yeah, go ahead. Right. Right. Any other questions? No bathroom breaks. Good. Yeah.
How long, or so we're still gonna have lecture afterwards and everything?
Yes.
Oh, okay.
Did you ever had a 5-hour exam in math? Because our class is 5 hours. Yeah, but time flies when you're having fun. I mean, you know, goes by like 5 minutes, right? Yeah.
Oh yeah.
All right, so if that's it, I'm just going to shut the stream, and